Hello dear student, I am Hrishikesh Labhde, working as an assistant professor at Srimati Vimlaben Khimji Tejokaya, S.V.K.T College, Devrali Camp, Nasik. I welcome you all in this online LMS lecture series. In today's lecture, we are going to learn about chromatography, its introduction and type of chromatography. So let's get started. Chromatographic techniques. Session agenda. In today's lecture, we are going to learn about chromatography, type of chromatography, its classification. Then we will study about column chromatography, ion exchange chromatography, paper chromatography, TLC, that is thin layer chromatography, advantages and limitation of chromatographic technique, and application of chromatography in the analysis. So what is chromatography? Chromatography is an analytical tool used for separation, identification and purification of an organic compound of a mixture. This technique of chromatography was introduced by S.V.K.T and developed by Martin and co-workers in 1941. Chromatography involves two steps. First is stationary phase, which is a finely divided solid such as alumina, silica gel or a liquid coated on an inner wall of solid supported acts as a stationary phase. Second is mobile phase. It may be liquid or gaseous. It is movable phase. Chromatography is a physical process where the components of a mixture are separated as a result of their differential distribution between stationary and mobile phase. Now, principle of chromatography. Mobile phase acts as a driving force while stationary phase acts as a retarding force. Retardation is due to the adsorption of component on a solid surface or partition of a component between two phases. Constituents of a mixture differ in their adsorption or desorption behavior and hence get separated from each other. Matchbox model. This explains the separation mechanism of two solutes on the basis of their different solubility in two solvents, that is stationary and mobile phase. It explains the mechanism involved in liquid-liquid chromatography. Now we will study about types of chromatography, its classification. Chromatography first divided into two types if it separate on a basis of adsorption or it separates on the basis of partition. In case of adsorption, the stationary phase is always solid, and in case of a partition, stationary phase is liquid. The adsorption chromatography further divided into two types. The mobile phase is liquid or the mobile phase is gas. If the mobile phase is liquid, then different techniques are column chromatography, thin layer chromatography, ion exchange chromatography. And when the mobile phase is gaseous in nature and the solid stationary phase is solid in nature, then the chromatography is gas chromatography. In case of partition chromatography, the mobile phase may be liquid or may be gas. If it is liquid, then the techniques are paper chromatography, gel chromatography. If the mobile phase is gaseous and the stationary phase is liquid, then gas liquid chromatography. Now we will study the concept of theoretical plate and efficiency of column chromatography. The efficiency of column chromatography is described in terms of theoretical plate. During the chromatographic separation, there is a distribution and redistribution of solid between stationary phase and mobile phase. Equilibrium between solute and solvent is due to theoretical plates present in the chromatographic column. In one chromatographic column, there are several thousand such plates. As the number of theoretical plate increases, the column efficiency for the separation also increases. For a given length L of a chromatographic column, number of theoretical plate N are more if height, the h of a HETP is small. Thus, N is equals to L divided by H. Now we will study the principle of adsorption chromatography. Stationary phase is solid in the column chromatography. Stationary phase adsorbs the component of a mixture while mobile phase desorbs the component of a mixture. Different components of a mixture absorb to different extent and thus the separation is observed. Partition chromatography. In partition chromatography, the stationary phase is liquid, that is the liquid coated on the solid surface. Separation takes place due to the differential partition, that is distribution of component of the mixture. Now we will study about preparation of column. Column is prepared by carefully packing solid materials such as silica gel, alumina, etc. Height of column is 10 to 19 cm and inner diameter is vary from 0.5 to 2 cm. While preparing a column, care is taken that no air bubble should remain in the column. At least half of the column is filled with the stationary phase for the separation. Now we will study the mechanism of method of separation. A small amount of mixture to be separated is placed at the top of the column. The mobile phase is called as eluting solvent. It is poured into the column with a constant rate. As solvent passes over the sample, band desorption or a partition of the sample component takes place. A component which is weakly held or less absorbed is moved first, while the component which is strongly absorbed is moved after. Thus, the different zone of a sample component are formed in the column chromatography. Separation takes place on the basis of extent of adsorption rate of a different component of a mixture on a solid surface. Elution. The solution coming out of the column is called eluate. Different zones of a components are eluted by mobile phase and collected in a separate container. This is a diagram of a column chromatography. The column at the bottom we see the cotton plug, then the solid packing material such as silica gel or alumina gel is packed and the sample mixture is placed on the top of the solid phase. And at last we pour the solvent, that is eluting solvent, for the separation, and as the solvent is passes below, it separate the sample mixture into corresponding bands. Now we will study about ion exchange chromatography. Properties of ion exchange. They are insoluble in water and organic solvents such as benzene, carbon tetrachloride, ether, etc. They are chemically inert and denser than water. They are complex in nature. They have active ions that can exchange with other ions present in the surrounding solution. Cation exchanger. These are the resins having sulfonic or carboxylic group. The cation exchange can be represented by the following equation. Now we will study about type of cation exchanger. First is strong acid resin. They contain SO3H group and they are effective from pH of 1 to 14. These are used for separation of amino acid, vitamin, peptides, rare earth elements. The example are Dowex50, Dowlite C20, Amberlite IR120. Next type is weak acid resin. They contain carboxyl group and they are effective from pH range of 5 to 14. These are used for the separation of transition metal, acid, antibiotics and organic bases. The commercial name of such a resin are Amberlite IRC50. Now next is anion exchanger. These are the polymers of having amine or quaternary ammonium group. The anion exchange can be represented by the following equation. Now there are further two types of anion exchanger. First is strong base resins. They contains amine group. They are effective from pH range of 0 to 12. These are used for the separation of alkaloid, fatty acid, vitamin B complexes. The example of such a resins are Amberlite IRA400. Weak base resin is the next type. They contain primary, secondary or tertiary amine group and they are effective over the pH range of 0 to 9. They are used for the separation of anion and amino acid. The example of such a resins are Amberlite IR45. Now we will study about ion exchange chromatography, type of exchanger, functional group and trade name are given in the image. Preparation of column. Procedure of a preparation of column chromatography is used for the preparation of column of ion exchange chromatography. In this column, the ion exchange resin is used as a stationary phase. Elution. The process of removing the exchange ion from the resin is called elution. Solvent used for elution is called eluent, and solution coming out is known as eluate. Ion exchange chromatography. Application. It can be used for laboratory separation, purification of water, extraction of metal, etc. First is separation of metal ion or ion exchanger. Metal ion are first converted to anion complexes by using complexing agent. For example, iron can be converted to ferric chloride. Concentrated HCl can form complex with many metal ion except alkali metals. Thus, these metals can be easily separated by using concentrated hydrochloric acid. When there are many metal ions, they can be separated by decreasing the HCl concentration to a level at which Kd of other metal is low. Now, second application of ion exchange chromatography is separation of amino acid. Adjustment of suitable pH is very important in separation of amino acid. As we know, amino acid exists in three forms. Positively charged amino acid are separated by using cation exchanger, while negatively charged is separated by using anion exchanger. Amino acid also exists as a zwitter ion at isoelectric point. Zwitter ion is an ion in which both the positive and negative charge are present on the same molecule. This form passes through both cation and anion exchange resin and gets separated. These are the three forms of amino acid. Third application of ion exchange chromatography is purification of water. Deionized water is a water free from any cations and anion impurity. Water is allowed to pass through a mixed ion exchange resin. Cation and anion present in a water exchange with the resin. The deionized water are widely used for a conductivity experiment, used for biological studies, used in a high pressure boiler, used for the preparation of lead storage battery, and also for the preparation of silver nitrate solution. Now we will study about paper chromatography. Analysis of unknown substances is carried out mainly by flow of solvent or specially prepared filter paper is called as paper chromatography. Paper chromatography is a partition chromatography. In this chromatography, water acts as a stationary phase and paper, which is solid support on which stationary phase is coated, and an organic solvent is a mobile phase. Mobile phase move over stationary phase by a capillary action. The solute, which are more soluble in water, move slowly, while solute more soluble in mobile phase move with a faster rate. Thus, the separation of component takes place. Steps involved in the paper chromatography. First is application of sample on a paper. The Whatman filter paper of a suitable size is used for this. A thin pencil line is drawn at the 2 cm from a bottom. A small quantity of mixture is dissolved in minimum quantity of volatile solvent, and by using a capillary tube, the sample is placed on a paper. Saturation of the tank. The atmosphere of a tank must be saturated with a mobile phase before starting the development. For this, the solvent is added in the tank and the tank is closed with the lid. Third step is development of chromatogram. The paper is placed in a chamber with one end dipping in the developing solvent. There are two types of development: ascending development and descending development. In ascending development, developing solvent move in upward direction by capillary action. On other hand, in descending development, the solvent move in a downward direction. Now the next step is the process of separation of component of a mixture in the form of bands or spot of a pure substances at different places of a chromatogram is known as development of paper chromatogram. Last step is location of a spot. Physical method. The paper is observed under UV light to locate the color component. Other is chemical method, use of charring agent. Colorless component of in a UV light can be converted into colored component by using a chemical reagent such as iodine crystal, K2Cr2O4 crystals, methyl alcohol, ethyl alcohol, etc. for and neon hydrogen spray, especially for the amino acid. Paper chromatography. Last is the identification of a compound. Identification is done by calculating retardation factor RF value. RF is the ratio of distance travelled by given substances from origin to the distance travelled by a solvent from the origin. Under the constant experiment condition, RF value are often reproducible. The application of proper chromatography is for separation of small biochemistry substances, separation of amino acid, separation of proteins, separation of organic as well as inorganic substances, analysis of mixture of sugars. Next is thin layer chromatography. Is an important technique. It is solid liquid chromatography, consists of a solid stationary phase which is a alumina plate or silica coated plate on a glass, and liquid phase is a maybe any solvent system. Principle. It involves the distribution of a component of a mixture to be separated between two phases. Different components of a mixture have a different solubility and adsorption in two phases. In TLC, separation of individual substances is based on their relative affinity towards stationary and mobile phase. Component with more affinity towards stationary phase travels with a slower rate. Commonly used stationary phase are silica gel, alumina, cellulose powder, and commonly used mobile phase are a volatile solvent in a pure form such as ethyl acetate, ether, benzene, CCl4, etc. Preparation of a surrey. A small amount of a stationary phase material is dissolved in a suitable solvent. Dry TLC plate is dipped into a slurry for development of a thin layer uniform TLC. Plate is dried to evaporate the solvent and activated at 110 degrees Celsius. Chromoplate. Plate having uniform layer of finely divided solid on it is known as chromoplate. Now later we done the saturation of tank. There are again three types of thin layer chromatography. First is adsorption chromatography, liquid-liquid partition chromatography, and ion exchange TLC. And fourth is size exclusion TLC. Mobile phase used in TLC is ethyl acetate, petroleum ether, benzene, CCl4. Generally, different solvents are mixed for the better separation. Detection of the spot. We used iodine vapors, sulfuric acid, neon hydrogen spray or UV light for the detection of a spot. This is how this is the diagram for TLC. We can calculate RF value. Advantage of TLC over paper chromatography. It gives very sharp separation, is used in organic, inorganic and biochemistry. It is faster than paper chromatography. The RF value is reproducible and it can be used for adsorption, partition and ion exchange. These are some advantage and limitation of chromatographic technique. Limitations are incomplete recovery of a sample. Adsorption depend on physical state of adsorbent. It is difficult to get adsorbent of a same quality every time. The advantages are, this is very sensitive technique, use only 0.1 microgram of a compound, and apparatus and equipments are easily available and simple to use. Applications of chromatography. It is used for the purification and identification. In a synthetic chemistry, it is used to find out the progress of a reaction and quality of the product. Detection of a mixture, terpenoid, vitamin, chlorophyll, steroid, etc. Identification of sugar in urine, and it is highly used in forensic science for detection of poison and metal ions. Summary. In today's lecture, we learn about chromatography, type of chromatography, We discussed about column chromatography, ion exchange chromatography, paper chromatography, thin layer chromatography. Later we discuss about advantages and limitations of chromatographic technique and applications of a chromatography at the end. Students have to write the chromatography, what do you mean by chromatography, what is this technique, write a note on chromatographic classification, and in third question student have to explain thin layer chromatography. This is session assignment. Thank you.